Find the function whose derivative is f of x equals 1 over x squared plus 2x, and it passes through the point -1, 1. The graph of the function whose derivative passes through this point, not f of x. To find the function whose derivative is the little f of x, we need to find the capital F of x such that when we take derivative of the capital F, we get the little f. As of now, the only method we have is guess and check. We rewrite f of x as x to the -2 plus 2x. We can guess that to get 2x, we would need an x squared because the derivative of x squared is 2x. Similarly, to get to x to the -2, we would need to have an x -1 because when we take the derivative of x to the -1, we lower the power by 1. This is only a guess. We still need to check this. F prime of x is -1 x to the -2 plus 2x. Almost the same, except for that negative sign. And so how do we correct this so that we don't have the negative? We can start with f of x equals -x to the -1 instead. And don't forget to have a plus c, an arbitrary constant. Once we update or correct our guess, we still need to check this. F prime of x is negative times negative is a positive, x, and then -2 plus 2x plus 0. So this guess is correct. We will use capital F of x equals -x to the -1 plus x squared plus c, or capital F of x equals -1 over x plus x squared plus c. There is another condition here. The graph of the capital F of x has to pass through the point -1, 1, meaning when x equals -1, the capital F of -1 is 1. We plug -1 into x. The right hand side is -1 over -1 plus -1 squared plus c, and the output is 1. -1 over -1 is 1. -1 squared is positive 1. C is therefore -1. When we made our initial guess and we checked that it was correct with a plus c, this is called the general solution. Using the initial condition, we found capital C. We now have what we call the particular solution. The solution is therefore f of x equals -1 over x plus x squared minus 1.